right, so looking at section 1.2, applications involving linear equations. We just looked at in section 1.1 how to solve linear equations. Now we're going to look at how we can solve some word problems using those linear equations. So we've got just 6 examples to work through. We'll work through these together again. Feel free to pause this video, try it on your own, or replay it as many times as you need. So let's look at this first one. A family arrives at the Walt Disney World parking lot. To get from their car in the parking lot to the gate at the Magic Kingdom, they walk 1/4 of a mile, take a tram for 1/3 of their total distance, and then take a monorail for 1/2 of their total distance. How far is their car to the gate of the Magic Kingdom? One of the main things I think that's a key first step, but a lot miss, is identifying your variable. Okay, what don't we know? First thing we got to figure out, the first thing we got to know is what we don't know. And it's this right here. How far is their car? How is it from their car to the gate of the Magic Kingdom? So I'm going to let that be C. So that is the distance from the car to the gate. So I think the first thing you need to do is identify what we don't know and give that a variable. So now let's start working our way through this. All right, so it says they start off by walking 1/4 of a mile. So let's just represent that with 1/4. Then they walk another 1/3 of their distance. Well, the original distance was C, so 1/3 of that would be 1/3 times C. Then they walk 1/2 of their distance. Well, 1/2 of their distance, if their distance is C, is 1/2 C. And now they have covered that entire distance. So now we've got our equation. Once we've got an equation, now it's just like section 1. We just have to solve this. So I've got some like terms here. So 1/3 plus 1/2. You can grab your calculators and do this, or this is 2/6 plus 3/6. I think that's about 5/6. So that's 5/6 C. And it still equals C. I'm just going to recopy this up here so I've got a little bit of room to work as I solve this now. So this C has a 1 in front of it. So again, I'm dealing with an equation with variables on both sides. So I get rid of the little guy. I'm going to do that like we talked about in the last video by subtracting 5/6 C. I get 1/4 equals 1/6 C. And then I want to divide by 1/6. Both sides. And 1/4 divided by 1/6 would be like 1/4 times 6/1. So that would be 6/4 or 3/2 or 1.5 miles. Their car is about 1.5 miles from the gate. But again, I think the key thing here was identifying our variable and then just using the information in the problem to somehow write this equation. Let's look at the second one here. So we've got 3 consecutive odd integers, so that the sum of those 3 integers is 5 less than 4 times the first. So again, identify our variable. And we got 3 different things going on here. We got all 3 odd integers, but I'm going to let n be that first odd integer. So now the next odd integer would be n plus 2. To get from one odd integer, I add 2. To get from 3 to the next odd integer, which would be 5, I add 2. To get from 13 to 15, I add 2. And then I've got 3 of them, so the next one would be n plus 4. That's my next odd integer. So now I'm ready to start writing my equation. So find 3 consecutive odd integers, so their sum. So the sum of these, well, that's adding them all together. N plus 2 plus n plus 4. There's the sum of 3 odd integers is, that's my equal sign, 5 less than, so that's something, minus 5, 4 times the first one. And now here's my equation. Okay. Again, I look and see if I can simplify, and on the left-hand side, I've got n plus n plus n, or 1n plus 1n plus 1n. That's 3n. And 2 plus 4 is 6. Not much I can do over here, so that's still just 4n minus 5. I've got an equation with variables on both sides, so I can subtract 3n on both sides. That zeroes out, so I get 6 equals 1n minus 5. And then I can add 5 to that, so n is 11. Now that's just the first one, so my first odd integer is 11. It told me or asked me to find all three, so if 11 is the first one, 11 plus 2, 13 is the next one, and 11 plus 4. And now I just like to check this out. Does the sum of these equal 5 less than 4 times the first? Let's see, the sum of these, 11 plus 13 is 24. If I add those up, I get 39. Let's see, 5 less than 4 times the first. 4 times 11 is 44. 5 less than that is 39. Pretty confident that I solved that correctly. As we look at this next one, as soon as they start talking about rectangles and squares, I like to draw pictures. All right, so we've got a rectangle that's 3 inches wide, but we don't know the length. And we've got a square that's 9 inches on a side. So it says this rectangle has the same area. Well, area is length times width, or base times height. So I know that 3 times L has to be equal to 9 times 9. So now I'm ready to solve this. So 3L equals 9 times 9 is 81. Divide by 3 on both sides, and L is 27. So the dimensions of this rectangle are 3 by 27. But again, anytime you see rectangles, squares, any sort of shape, I love drawing pictures because it really helps me see what's going on there. This next one talks about simple interest, just real quickly. The simple interest formula is interest equals principal times rate times time. Okay, principal is the amount of money that you deposit. R is a rate, usually written as a percent, and T is time, and that's given in years. So interest is if you put money in the bank, they periodically deposit more money into that account, or if you borrow money, this principal may be money borrowed, and then at the end you have to pay not only the money you borrow, but some interest on top of that. So this is the simple interest formula that can help us estimate that. So you win $24,000 and you decide to invest the money in 2 different investments, one paying 18% and the other paying 12%. A year later, you've got a total of $27,480. How much did you put in each account? So I'm going to let X be the money put in, the 18% account. Now, we could go a different variable here, but I want to keep it in terms of one variable. All right, so if I had $24,000 and I put X of it in that 18% account, what was left over would be 24,000 minus X. So that would be what would be in the 12% account. So let's start writing this equation here. So how much money did I make in the first one? Well, principal, that we don't know, times rate, 18%, written as a decimal, is 1800ths. times time. Now, the nice thing they did here, it was just a year later, all right? So we could put times 1 if we wanted to there, but I'm not going to put that in. So there's the money I made from the first account. Now, the money I made from the second account, principal, would be $24,000 minus X times the rate, 12%, written as a decimal, and times the time, which again would be 1. But those two added together, the amount of money I made from this one and the amount of money I made from that one, would have to equal how much money I made altogether. Now, that's not that, because that includes my original $24,000. The amount of money I actually made would be the difference between these, and that would be the $3,480. But now, looks like I've got an equation. I've got some distributed property. I'm going to rewrite this. So this is 1800s X. I want to do 12% times 24,000, and I get 2,880 minus 1200s X equals 3,480. I've got like terms, 1800s X and 1200s X, and again, that's a negative if you want to think of it that, excuse me, if you want to think of it that way, that's 600s X plus 2,880 equals 3,480. But now I'm at a two-step equation. I take away 2,880 on each side, 2,880 over here, and I get, that should be 600ths, not 6/10. 600ths X equals 600, 33,480 minus 2,880. And divide by 600ths on each side. I get X equals $10,000. That's how much was in the 18% account, because that's what we let X be. And the amount of money in the other one is the rest of it, 24,000 minus X, or 24,000 minus $10,000. So that means I had $14,000 there. All right, let's do a little chemistry. It says for a certain experiment, a student requires 100 milliliters of a solution that is 11% hydrochloric acid, HCl. The storeroom only has 5% HCl and 15% hydrochloric acid. How many milliliters of each should they mix to get 100 milliliters of the 11%? Again, I've got two unknowns here. How much of this do I need and how much of this do I need? I'm going to let X be the amount of 5% solution. And since I want 100 milliliters altogether, again, I could go a second variable here, but then I need two different equations to solve it. I want to keep this in terms of one variable. So if I need 100 milliliters altogether and I've used X of it here, the rest of it must be 100 minus X, and that's my 15% solution. So now I'm going to focus on the two mixtures. So if it's 5% hydrochloric acid, okay, how much pure acid is that? Well, that is 5% of whatever I have. And I have a total of X milliliters. The other one is 15%. So 15% of whatever I have. And those two added together have to equal, well, the other one is 100 milliliters of 11% hydrochloric acid, so 11% of 100. Or let me just do that real quickly to put a little context here. That means this 100 milliliters, 11 milliliters of it is pure acid. All right, looks like I've got some distributed property to do over here, so I've still got the 500ths X plus 1500ths times 100 is 15 minus 1500ths X. 1500ths times that X there, if we look at that as subtraction. I've got like terms. 500ths minus 1500ths is negative 1/10 X plus 15 equals 11. Now I've got a two-step equation. Subtract 15 on both sides. So it's negative 10 whoops, negative 1/10 x equals negative 4. Transfer this up here. So negative 1/10 x equals negative 4. Divide by negative 1/10 on both sides. And x is 40. So there was 40 milliliters of this, and the rest of it, 100 minus 40, the rest of it was the 15% solution. All right. One last example here, and this is a distance, rate, and time problem, and we've got a plane flying into the wind and against the wind. Okay. Key thing you need to know here, just make a little note, is that distance equals rate times time. So we've got a Cessna 150, and it averages 150 miles per hour in still air. If it has a tailwind, it's able to make this trip in whatever it is in 2 1/3 hours. When it's coming back, the headwind, the wind blowing against it, it's only able to make the trip. It takes a little bit longer, 3.5 hours. How fast is the wind blowing? So let's look. Now again, the thing I don't know is the average wind speed. So I'm going to call that W. But now I'm going to look at this. I know rate times time is going to give me distance. So let's look at this trip with the tailwind. The rate, okay, is the plane going by itself plus whatever the wind is pushing against it. The wind is helping it along here, so that's actually going to increase the speed of the plane. And the time, they give us that, is 2 1/3 hours. Now, on the way back, the rate or the speed is the speed of the plane minus the wind speed, because that wind is actually pushing against it and slowing it down. And its time is 3.5 hours. So this is distance, rate times time. This is distance, rate times time. And since it's the same trip, those two distances have to be the same. And now I've got an equation that I should be able to solve. So I do the distributive property here. So 2 1/3 times 150. 2 times 150 is 300, and 1/3 of that is another 50. So you can check that on your calculator, but I think that's 350 plus 2 1/3 W. And here, 3.5 times 150 is 525. 3.5 times negative W, or minus W, is negative 3.5 W. Got an equation with variables on both sides. Let me get rid of one of them. So I'm going to add 3.5 W to both sides. So you get your calculator and add these up. 2 1/3 plus 3 1/2. I get 5 5/6 W plus 350 equals 525. And now it looks like a two-step equation. Subtract 350 on both sides. I get 5 5/6 W. 525 minus 350 equals 175. And then divide by 5 5/6 W on both sides. So if I do 175 divided by 5 5/6, W is 30, which is the wind speed. So the wind is blowing at about 30 miles per hour. So a lot of different examples. Hopefully these examples help you. Go ahead. If you have any questions, come see me. But otherwise, go ahead and get started on page 112 and 114 and have those problems done for me.